Okay, so we are talking about equivalent expressions, and this is lesson 19, session 2. And when talking about equivalent expressions, we want to be able to look at a word problem, create an expression for it. And this is something we did do toward the beginning of the year as far as looking at word problems and creating expressions for them. It's just that now, if you take a look at this problem, it says write two expressions for the total cost of both services. So we need equivalent expressions since we need two to get the same value. So it says the Romano family pays for a streaming movie service that costs $8 per month. They want to add a second movie service for $D per month. Write two expressions for the total cost of both services for 3 months. One expression should be a sum of two terms, and one should be a product of two factors. So, when looking at this particular problem, we want to say, okay, service number one, they said that that was $8 for every month, right? And we know that we're calculating cost for 3 months. So if it's $8 for every 1 month, then we could take that 8 and multiply it times 3 to give us how much it's going to cost for service number one. So service number one, 8 times 3 is 24, right? Then we're going to take a look at service number two, and we don't know how much it costs, and they want us to use D for dollars, the unknown amount of dollars. However, we still are looking at 3 months worth of service. So when we have a variable being multiplied by a number, we know that we can write it as those two side by side. So we have 24 and we have 3D. And we want both services for that same amount of time period. Well, if we want both, then we are adding those together, which gives us a sum. So we have 24 plus 3D. That is a sum of two terms. We have term 1 and term 2. Now we can create an equivalent expression. If we look back at what we did earlier in the week or with the expressions review, then we know that we can find a common factor. Well, 24 and 3 share a common factor. In fact, we did it right up here at the beginning. They share a factor of 3. So I can pull out that factor, and then I can say, okay, 3 times 8 is 24. And then if I pull out the 3 there, then I'm just left with D. Because 3 divided by 3 is 1, so it's 1D. And you can put a 1 in front of the D if you want to, but it's not necessary. So now we have two expressions that are equivalent to help us figure out how much both services would cost together. So that is our answer for the first question. All right. This is just a way to model this. So there's something called algebra tiles, and they come in little squares, a stick, and then there's a larger square, and they have a color on each side. So one side of the small square might be yellow and the other side red. That's to represent positive versus negative numbers. But we won't be adding and subtracting positive and negative numbers with our expressions or equations, so we won't get into the different colors. Just make sure that if you wanted to model this and you had algebra tiles in front of you, that you use one color to represent each part. And each part is its own term, which means it's represented with a different type of block or tile. So it says each square tile represents $1. So this little yellow is $1. And each rectangular tile, so that's the green, represents D dollars, the unknown amount. So we know it's, something, we just don't know what it is. So with this one, we knew that the first service for 3 months was going to be $8. So if you look, check out how many are in each row. We have 3 rows. And we have 8 in each row. So 3 rows of 8. And if we add that all together, of course, we get 24, right? And then we know we want 3 months of service, so that's why they continued with the 3 rows. We just aren't sure how many squares go in each row. So we leave that as an unknown. So this model would represent 24 plus 3D. So that is one way to find the expression. All right, in this particular problem, we're going to use distributive property to rewrite this expression. So right now, the expression is 5x plus 3, and that is being multiplied by 2. You won't always see the parentheses around the second number here. Sometimes that number would just be by itself. The thing that we need to remember is that this 2 is distributed to each term. All right, so 2 times 5x would be 10x, and then plus 2 times 3 would be 6. So now we have the sum of 2 terms. Sum, and we have 1 term and then 2 terms. The next problem says, which expression is equivalent to 63 and 56? If we look back at what we've done previously, we know that anytime we have the sum of 2 numbers, we can create an equivalent expression using distributive property. The only thing is they have to share a factor. So what you want to do is you want to find a common factor between these 2 numbers. In this case, they've given you some answer choices. So you should be able to look at that list there and decide, okay, 7 is a common factor. And then you just need to check and see which one matches up with what distributive property should say. So let's take a look at D first. They have 7 and then 9 plus 56. So with distributive property, what they're saying is 7 times 9 is 63. Well, that's true, right? But 7 times 56 is not going to be 56. So this expression is not going to be equivalent. It's not going to match. So let's check out A and just double check and make sure that it does. 7 times 9, yes, that's 63. 7 times 8, yes, that would be 56. So our answer here is A. A is the equivalent expression. And then the last problem for this session. A company sells fruit cups in packs of 4. The packs currently weigh 20 ounces. The company plans to reduce the weight of each cup by N ounces. The expression 20 minus 4N represents the new weight in ounces of a pack of fruit cups. So you didn't have to come up with the expression. They've got it there for you. What you do need to do is rewrite the expression for the new weight as a product of 2 factors. Show your work. So just like with the sum of 2 numbers, if they share the same factor, even though it's a difference and not a sum, if they share a factor, we can pull that factor out. So 20 and 4 do share a factor. They share the factor of 4. 4 times what equals 20? 4 times 5. Minus 4 times what equals 4? 4 times 1. So we're left with 1n. And again, the 1 is implied, but you can write it there if you would like to. So now we have created an equivalent expression. So that is the very simplified version of finding equivalent expressions. In our next session, we will move a step further.